Alright, in this video we're going to be talking a bit about how to solve radical equations. First of all, we define a radical equation as any equation that involves a radical expression, that is, it has some sort of a root in it. Our basic solution strategy here is to try to raise both sides to a power so as to cancel the radical expression that presents itself. There are a few issues with this though. Let's go ahead and by working this we'll see what happens. So here the first thing is we want to isolate the radical expression to be able to square it out in this case. So let's go ahead and add x to both sides. X plus 2, or 2 plus x if you prefer. And now we're going to go ahead and square both sides. When we square both sides, this squares out. Over here, we have x plus 2 squared. Well, please don't forget that's a foiling, namely it's x plus 2 times x plus 2. So we get x squared plus 2x plus another 2x, so 4x plus 4. So when we FOIL out, we end up with this. Okay? Now, that being said, we now go through and say, oh, well, let's get all of our terms to one side and see what happens. When we get all of our terms to one side, we get 0, taking those to the other side. X squared plus 2x, because we subtract 2x from both sides, and then we subtract 7 from both sides and get negative 3. So we now say, oh, that's a quadratic, so let's see what we would get. The solutions to this quadratic will be what? You can factor it. It factors into positive 3 and negative 2, which means x equal negative 3 and positive 2 should be solutions. If we plug negative 3 in, so let's go ahead and if we plug negative 3 in, we get 9 minus 6. Yeah, so that is a solution. And 2, 4 plus 4 is 2. Yeah, 4 plus 4. That's not right. 3 and 1. Sorry, it factors into x minus plus 3, x minus 1. So 3 and 1. If we plug 1 in, we do get, yeah, solution. Okay, so you would think these are the solutions to this. But this is where, with radical equations, you really need to check your solution. And the reason why is that extraneous solutions tend to crop up with this. When you're squaring, basically, the reason is that you may be adding solutions. So by squaring both sides, we may be adding solutions. So you really need to check. This is why, for the most part, I've been writing out and checking my solutions as I go along. So if you've developed that habit, awesome. If you haven't, now is the time to start. Because if we plug negative 3 in, we get square root 2 times negative 3 plus 7 minus negative 3. What does that give us? Well, that gives us 2 times negative 3 is 1. And we have 2 times negative 3 is negative 6, plus 7 is square root of 1 under there, plus 3. And what we end up with is we end up with 4. So that is not a solution. So this right here, not a solution. On the other hand, if we plug 1 in, we get square root of 2 times 1 plus 7 minus 1. What does that equal? Well, 2 times 1 is 2, plus 7, square root of 9, minus 1. That would give me 3. 3 minus 1 is 2. So that is a solution. So only x equals 1 is a solution. That is, negative 3 is extraneous. That was the word we used for it. Okay. So we sort of have two issues. Our first issue is, the first issue was that extraneous solutions tend to come up. Extraneous solutions tend to occur. And our second issue, we see that our second issue is we have to remember to FOIL. to FOIL. This can be an issue. It wasn't really an issue in the last one because I remembered, but it can become an issue for you, so be conscious of that. So as such, let's work another example. This example is a little bit more nasty. So first, we're going to try solving this the same way. We have 2x minus 5 equals 1 plus square root x minus 3. So we say again, we kind of need to worry a little bit here, so I'll put a exclamation point to remind us about issue number 1. So squaring, we get 2x minus 5 there. Here, though, we have to square this. And this is nasty to FOIL out. 2x minus 5 equals. So first would be 1 times 1. The outer would be 1 times root x minus 3. The inner would also be 1 times root x minus 3. Usually I shortcut that step, but I want to be careful here. I just put those together. Plus root x minus 3 times root x minus 3, which will cancel and give me x minus 3. Okay? Well, that means we have 2x minus 5 equals 1 plus 2 root x minus 3 plus x minus 3. Well, now we're going to try to isolate this square root. By isolating that square root, let's take everything to the other everything else to the other side. So if we subtract 1 over, we get 2. So let's first subtract the x. Subtracting the x, we get x. Subtracting 1, we would get negative 6, but then we add 3, so we get positive 3. Equals 2 square root x minus 3. If we square both sides of this now, we end up with, so again, we got to be a little bit wary, x plus, so foiling this out, we get x squared plus 6x plus 9, equals 4 times x minus 3. So now we distribute out and we get, distributing out, we get x squared plus 6, we get what? X squared, we can expand this, distribute the 4 and then bring it to the other side. So we'd have 4x, subtract that from there, you get plus 2x. Here you'd have minus 12, add that and you get plus 21 equals 0. 21, let me just make sure that I'm doing this right. No, not 21. Yeah, no, yes. Because 4, 12, yeah, 21. Okay, let's use the quadratic formula to solve this. X equals negative 2 plus or minus the square root of 4 minus 1 times 21 all over 2 times all over 2 times a. Yeah, 2 all over 2 times 1, right? Minus 4 times 21, sorry. That's a positive 21, right? Let me make sure my steps are correct here. If I add 3 to both sides, I get 2, but minus 1 gives negative 3. Ah! I made a mistake. This is negative 3. This is, so this, when I expand out, would be negative 6x plus 9. So I get a negative. So that looks right. That looks right. So negative x minus 3. Here I'd have negative 6x, but then when I add 4x to negative 6x, I get negative. No, I get negative 10x. So this is going to have to be redone. And I end up with x squared minus 10x plus, this is no longer correct now. Well, no, it is. Yeah, no, that's still correct. So I get x equals negative negative 10, so positive 10, plus or minus the square root of 10, which is 100, minus 4 times 21. All over 2 times 1. However, here we have a bit of a problem. What is the problem? The problem here is what we get under here is 4 times 21 is, no, there's no problem. X equals 10 plus or minus 100 minus 82 is 18 all over 2, which equals, what? We have 10 plus or minus 18 divided by 2 is 9, so we have a 3 root 2. Simplifying and over 2. Let's check that. Checking is going to be really, really, really nasty. Is that 18? Yeah, that's 18. Yeah, okay. I'll let you check it by plugging in and playing around. It's going to be a numerical check, so use a calculator to do it. But just be aware you may or may not get an extraneous solution. Now let's have you try one of the problem that's similar to the first type that I did. Go ahead and solve that equation, and on the count of 3 I'll reveal the answer. 1, 2, 3. So here we go through, square both sides. Again, I like to put the exclamation point to be aware that we might be throwing in an extra solution. Going through, we end up with the solutions x equal -9 or x equal 4. We go through and check. We find that x equal -9 actually satisfies the original equation, but plugging in 4, we end up with 0 equals 4, which does not. So x equal 4 is an extraneous solution, which means x equals -9 is the only solution we have. There is a third problem as well, namely, we have to be careful. We have to be careful with exponents. So issue number 3 is be cautious with exponents. Be cautious with exponents. Okay. Namely, what if we want to solve an example like this? This example, we can go ahead and you might want to raise to the 3/2, but let's be careful and write what we mean here. So we really mean x minus 4 squared cube root equals 25. Let's cube both sides first. Okay? Or, actually, let's do the square first. We can do either one. So, doing the square first, if we square root both sides, we end up with the cube root of x minus 4 equals, equals plus or minus the square root of 25. Now we go ahead and we cube both sides. By cubing both sides, we preserve whatever sign we have. So we have x minus 4 equals plus or minus 25. Of course, the square root of 25 is 5. So cubing that will give us plus or minus 125. Well, that means we have two solutions. Either x equals, could be plus or minus, x equals 4 plus or minus 125. That means x could either be, if you had to do 4 plus 125, it's 129. But if you do x minus 4 minus 125, you get x equals negative 121. We again need to check to make sure we don't get any extraneous solutions. Plugging 129 in, we end up with x minus 1, x minus, what? X minus, check, we have 129 minus 4 to the 2/3. If we do that, we get 125. That would be the cube root of 125 squared, which gives me 5 squared, which is 25. So that works. If we plug in negative 121, negative 121 minus 4 to the 2/3 equals the cube root of negative 125 squared, which gives me negative 5 squared, which equals 25. So both are solutions. Work one more problem. Let's go ahead and have you solve this, and on the count of 3, I'll reveal the answer. 1, 2, 3. So plugging in, so here you solve it very similar to the last problem, namely I rewrite it in its radical form with the exponent. Then I go ahead and I take the square root of both sides, then I go ahead and cube both sides, and then I find both solutions that way. Checking here, I just went ahead and used the calculator sort of notation. You can use a calculator to do this, so be sure to check. For more practice in solving radical equations, be sure to see the textbook, page 857, numbers 77 through 88. And in our next video, we'll finish off talking about solving equations with absolute value equations.